Okay, the next part is looking at discharging capacitors. Okay, so to discharge a capacitor, you first of all have to charge it, and that's why we've got sort of two parts to this circuit. The first part is, if we ignore this part first of all, we've got a power supply connected to a capacitor there. So what happens is you can charge the capacitor first of all by connecting it up to a power supply, and we know that the capacitor will reach the voltage of the power supply um, after a certain amount of time. So that's what we want to do first of all. We want to charge up the capacitor and charge it up to its highest voltage, so the voltage of the power supply. Okay. Then what we do is we then need to disconnect that power supply and start our timer. So we basically disconnect this power supply so we can ignore that part of the circuit and start the timer. Once we disconnect that power supply, the current starts flowing from that capacitor round the circuit, and the capacitor gives off its charge to the rest of this circuit here. So it starts off with quite a high current because the capacitor has a high amount of charge across it, but as it releases its charge, as it discharges, the current gets smaller and smaller until the capacitor has no more charge left on it. So if we measure the current flowing through that circuit, then we will notice that the current will start off high but get smaller as time goes on. So the current will decrease as time goes on. And also, we know that that capacitor will start off with a high voltage because it's got a high amount of charge across it. But as it releases its charge, the voltage across that capacitor will also decrease. So the voltage supplied to that little circuit there, because the capacitor is acting like a voltage supply, will also decrease as it releases its charge. So the voltage across that resistor or across anything in that circuit will start off high, but it will decrease and decrease and decrease as the capacitor basically gets rid of its charge. So if we were to plot the graphs of here, now these are a little bit more not complicated, but there's a reason that I've drawn two graphs for the current versus time. So we know that the current starts off high because the capacitor has a lot of charge on it and it's releasing a lot of it, but eventually it has less and less charge to release to the circuit. So we could draw this graph here, which would be fine because it starts off at high current and decreases with time. But the reason I've drawn this graph here is because actually the current starts flowing in the opposite direction than it would normally. So it's all built up on one side of the capacitor, then it flows in the opposite direction. So really, to be very accurate, we need to start off with a high current but a high negative current because it's acting in the opposite direction, and it decreases to zero as the time goes on as well. So this graph is correct, but this graph is more accurate because it's just showing the opposite to the graph that we saw earlier here. And the voltage across the resistor, which is what we're measuring there, which is this graph here, starts off at high voltage because the capacitor is supplying a high voltage because it's got a lot of charge across it. But as the capacitor releases its charge, the voltage across it decreases. So the voltage available to that resistor decreases. And what effect does increasing the capacitance or the resistance have on the discharging time? So again, think about that bucket. If you have a big bucket and you put a hole in the bottom, it will take longer for the big bucket to get rid of all the water in it, to release the water, than it would a smaller bucket. So increasing the capacitance increases the discharging time. And also resistance. So if you have a faster flow of water, you've got less resistance. If you've got a slower flow of water, there's more resistance. So if you increase that resistance, you decrease the flow of water. So it will take longer for it to release all of the water in that bucket. So increasing the capacitance and resistance increases, they both increase discharging time. So the important thing to remember from charging and discharging. Charging starts off at a high current but decreases as the capacitor becomes more charged, so it takes the charge away from the circuit. The voltage across the capacitor when it's charging starts off 0, but increases until it eventually reaches the supply voltage as the charge across it increases. When discharging a capacitor, the current starts off high because there's a lot of charge on the capacitor, but as it releases the charge, it gets smaller and smaller and smaller until it eventually gets to 0. And the voltage supplied to the circuit, because that capacitor is now the voltage supply, the voltage across the capacitor starts off high and decreases, so the voltage in the circuit starts off high and decreases.